You have a bunch of points in the plane, and every point in the plane is the midpoint of some two other points. Okay, and we wanted to show that S is infinite. So one thing I do want to tell you before we go on to this question is that here also we in some sense had applied the principle of Poya. That is, we reduced our problem to a simpler one, right? We were told that these points are on the plane R2, but we assume that the points are on the line to get an idea of what the hell is happening in this question. And the moments we assume that the points are on the line, most of you realize that, oh, this is a easy situation, or this situation at least we can handle, because if there are only finitely many points on the line with that midpoint property, then what are the 2 points of which this highlighted point is a midpoint, right? If you want this point to be a midpoint of 2 other points, you will have to produce something to the left of it and something to the right of it. And this is a problem because you started with the assumption that this is the leftmost point or the rightmost point. And this is how the extremality was in action, right? I think that is clear. And then what did we do? So now we have a bunch of points in the plane and we have some idea about this extremality. And we take, somebody says that here are a bunch of finitely many points where this property is true, that every point has 2 other points of which it is a midpoint. And you want to show that this is not possible. Something here is wrong. So if somebody actually produced this collection of points that are on your screen currently, you guys would have most likely told that person that, look, this guy here, how are you going to produce 2 points of which this is a midpoint? The one I am trying to highlight. Just one second. Right? So this point, and in general, I guess, yeah, it's good to just write it down. So if you have a point x, y, which is, and some other point, let's say x prime, y prime, then the midpoint. So the midpoint, yeah, I think I'll have to wait for just a minute for my pencil to reload.
That green thing will not go away. I think that needs surf excel or something. You can continue.
So the midpoint, this is something you guys know, but just to tell you, the midpoint of x1, y1 and x2, y2. So if you have 2 points in the plane, x1, y1, x1, y1 and x2, y2, then their midpoint has the coordinates x1 plus x2 by 2 and y1 plus y2 by 2. You know this thing. And you would have, if these were the set of points that were produced in front of you, you would have easily said that, look, this point xy cannot have 2 other points in this finite collection of which this is a midpoint. Why? Simply because look at the x coordinate of this point. It is the least. So let's just assume that we were drawing a coordinate axis on which this guy had the x coordinate to be 0. Then every other point has the x coordinate to be positive. So how is it possible that the sum of 2 positive numbers divided by 2 is 0? That's not possible. So, and it's also evident from the diagram that there are no 2 other points in this set of which xy is a midpoint, right? But we saw that someone can say that, okay, so wait a second. So after this, our idea was that, okay, then we seem to have a proof. Let's just look for the leftmost point of that finite collection. So here's the extremal part of it. We look for the leftmost point of the finite collection and we said that, okay, whatever that leftmost point is, call it xy, and then there is a problem. No 2 other points can have xy as the midpoint. But we saw that this has a slight problem. This argument has a slight flaw. That flaw is that someone can say that actually when you were figuring out the leftmost point of this finite collection, many points qualified as the leftmost point, right? Maybe let's say in this situation, only 3 points qualified as the leftmost point. And so when you picked up, so let's say maybe a few more, maybe 5 points. just because in this diagram, it's easier to do that. So just 1 second. So now when you say that, okay, I'm going to pick this point XY, and what are the 2 points of which this is a midpoint, that person could have said here and here. These are the 2 points of which this point is a midpoint. So here is your point A, XY, and A is a midpoint of these 2 points B and C, right? But in our mind, the extremality was really like, oh, if we take the leftmost point, like somehow the process in our mind is that if this midpoint property is true, you have to keep going left, keep going left, keep going left. And at that point, you have infinitely many points. How can you have finitely many points? This intuition was converted into choosing an extremal point to begin the argument. That is, let me just choose the leftmost point and try to get a contradiction that, oh, there is a point even further left. Okay, that's all we did. But this is not this is an objection here. This is a valid objection. But you can see that, so here is where you need some flexibility. You need to be nimble, as Bruce Lee used to say. The thing is that here we shouldn't give up. There are many ways to get rid of this problem. But one way to get rid of it is just to focus on this line itself. You know that for point A, any 2 points which claim to, play the role of B and C have to be on this line. They cannot be away from the line, because if even one of x1 and x2 is positive, the midpoint should have a positive x coordinate. That's not possible. So how do you get rid of this problem? Well, you just choose the lowest point on this line. Just choose this point. Let's call this point D. So you first ask that person, okay, let me choose the leftmost point you have in your collection. Then on that line, let me choose the lowest point that you have. Now you tell me which 2 points are there of which D is a midpoint. That is just not possible, because if that person wants to give you 2 points, let's say like E and F, right? So such that E and F's midpoint is D. You know E and F lie on the x-axis. We have just established that because of the x-coordinate equation. But if E and F lie on the x-axis, how is it possible? So both their y-coordinates. So yeah, the best way to think about it is just shift your y-axis. So instead of what is drawn in the diagram, just do this. So there can be, mind you, there can be points here. That is all okay. It doesn't matter. But the points E and F that person is referring to have to be produced on this line. And now there is a problem with the y-coordinate. The y-coordinate of E and F is positive. How is it possible that the average has the y-coordinate 0? The midpoint cannot have a 0 y-coordinate. Right? And this is a problem. So you will be able to derive a contradiction this way. And there are many ways. We saw other ways of taking care of this problem. But this is one way to take care of it. This is one way to take care of it. So again, our idea was that, okay, let's first simplify. Let's work on the line. That is a very natural thing to do. They have talked about the plane. Why talk about R2 when I don't even know the answer in R1? In R1, it was self-evident that, okay, I'll keep pushing you left, 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 left. Another way to say that is start with the leftmost point and get a contradiction. Let me try to do the same thing in R2. I try to do the same thing in R2. There is a subtle objection. But if I am just a little bit of flexibility, let's just get rid of the objection. Right? And that is also not very mysterious. It's just the same thing. We first pushed as left as we could, and then we went as further, south as we could. Okay.